second part of our vehicle tutorial series. Last time we talked about the general configuration of a physics-based car controller and controlled it with our keyboard. Now we want Polarith AI to take over. In our Tiny Wood mini-series, we already implemented a controller. Since we use physics and even vehicle physics, this time it's going to be a bit harder. The reason is that we have 4 different parts working together. Our AI calculates the best possible direction based on the setup and situation. Now we have the decided direction. Since it is a vector, we cannot pass it directly to the wheel colliders, because they need a motor torque and a steering angle. Last time we added the vehicle physics component to control the car directly. This component defines how the wheel colliders are used given the controller's input and comes with driver assistance systems like traction control. The controller somehow translates a given input vector into a format vehicle physics need. Thus, it is acting as a wrapper between Polarith AI and the physics world of Unity. It changes the vector 3, decided direction, into a steering angle and an acceleration value. Such setups are common in complex simulations. For example, if we have an aircraft that uses different control surfaces to move, we have to convert the decided direction into roll pitch and yaw angles, which then must be converted into proper add force and add torque vectors used by the rigid body. Now let's jump into the code. This time we do not implement the class line by line. We rather discuss it because it is complex. Furthermore, vehicle physics is an adaptation of the class that comes with Unity standard assets, so you might also have a look at this class. Okay, as you can see, there are a lot of fields and methods. We start with the most important method, that is the interface to our controller, the move method. It takes a steering magnitude and 2 acceleration magnitudes for moving forward and braking. As you can see, these values are clamped, since they are expected to be in ranges like -1 to 1. So they translate how strong the steering wheel is used from none to maximum positive and negative. Here are a couple of methods, some auxiliary systems like traction control, which we won't describe here. There are certainly better tutorials and literature for such topics. The 2 important ones are ApplySteeringAngle and ApplyDrive. ApplyDrive distributes the acceleration and brake values on the respective wheel colliders. As you can see, it is possible to define which wheels are used to accelerate and for braking like in the real world. Here we distinguish between braking and driving in reverse, though we won't make use of the reverse gear in this tutorial. The ApplySteeringAngle method is simple. We just have to scale our input steering angle with the maximum angle the wheels can move. This value is then applied to the wheel colliders we define as our steering wheels, most likely the 2 front wheels. Now we know everything to implement our controller. Before we do that, let's have a quick look at the update method. Remember the configuration of the car model in the first part? Here we use our single wheel meshes to animate them. This is easy. We just have to fetch the position and rotation from our wheel colliders using the getWorldPose method and apply it to the respective wheels. Okay, now to the vehicle controller. The first thing we need is, of course, the reference to an aim context instance. Then we somehow know that we also need the reference to the rigid body to check some situations. And we need our vehicle physics instance since we want to call move. It is also advisable to add the require component attribute. This way the field cannot be null when we fetch it from the game object. We start by getting the vehicle physics instance in Awake and also check the rigid body instance. If it is not present, we log a warning here since the user wants to know why the component is disabled. Now to the fixed update. Since we know the VehiclePhysics.Move method, it is clear that we need a steering angle and an acceleration and a negative acceleration for braking. We used the input of the aim context to set the acceleration. The decided value of the first objective is what we need. This value has a range of 0 to 1. A range from -1 to 1 would be better, so we map it accordingly. This way we can pass this value for both acceleration parameters. The angle is a bit more difficult. We can use the knowledge that the car always moves on the local XZ plane when driving the car. Thus, we can use the Y component of the cross product between decided direction and the forward direction of the car's transform. The advantage over using the angle method is that we get a signed value. We need to know the sign so we can be sure in which direction to steer. Furthermore, the cross function of the Y element has its extremum at 90 degrees and drops again to 0 when the decided direction is the exact opposite of the car's direction. This is desired behavior since we don't want the car to turn around in such case, rather than simply backing up. Now we just have to pass these values to the move method and voila! Before testing, we said that we want to permit the car from driving in reverse. We just need to check how much the body's velocity deviates from the actual forward direction. If it is greater than 90 degrees, we want the car to accelerate forward. We use maximum acceleration here, so the car gets as fast as possible out of the reverse state. We also noticed during testing that the car behaves better when we brake with full power. These 2 points are something you might want to change based on your needs. There was a lot of theory right now. But finally we can test if this controller works. Therefore, we just add a basic AI setup with aim-seek and add a simple target. Then we hit play and see for ourselves. Looks great. Now we have the non-trivial task to let this car drive in a roundabout properly. This is going to be the topic of the next 2 tutorials. So don't forget to subscribe. Thank you so much for watching and see you next week.